At this point, I would like to introduce you to our first keynote speaker. Today, we have Anita Graser. Anita is a research open source GIS developer and a well-known author to the geospatial community. She works at the Austrian Institute of Technology in Vienna, teaches Python for QGS, and serves on the QGS Project Steering Committee. She has published several books about QGS, including Learning QGS, QGS Map Design, and her latest project is Moving Pandas, a Python library for analyzing movement data. Spatial data visualizations are powerful communication and data exploration tools. So today, Anita will be exploring recent geospatial technology developments and how they can help us perform spatial analysis and present the results. Some of the technologies she will touch upon include open source, desktop GIS, and novel notebook-based tools, while highlighting challenges of analyzing and visualizing corresponding spatial temporal phenomena in GIS environments. So Anita, on behalf of the Canadian Cartographic Association, I would like to welcome you to our annual conference. It's very fortunate to have you join us here today, and with further ado, I will pass the screen off to you.
Thank you very much, Ted, for this introduction. I hope my slides are visible already. And as a next step, I will turn off my camera again because I was told that it would be helpful so we can see the slides in full. So we speakers should probably turn off our cameras. Okay. As Ted already introduced really well, I will be talking today about spatial data analysis and particularly the visualization part. I have to confess that I'm not a cartographer either, so my background is actually in geomatics and information technology, and I've been working with QGIS for over 10 years now, since back in 2008, so that was version QGIS 0.8. And I've been working with the Austrian Institute of Technology since 2011, mostly in the field of mobility and transportation research. So a lot of the examples that I will share with you today are about how to deal with data in this domain, so about the movement of people or vehicles or whatever entities that you might be able to track. If you want to reach out to me, if you have any questions, I always encourage people to visit GIS Stack Exchange, where I also serve as a moderator, and Ted was already so kind to mention some of the books that I've written, which can help you get started if you are not familiar with QGIS just yet. I want to frame the whole talk today in the context of what is now increasingly being called geographic data science. And I know lots of geographers and GIS people over the last couple of years. They were kind of frustrated with the data science hype, and a lot of people said, I suddenly realized that I'm a data scientist. I've been doing data science for the last decades, because so much in GIS obviously is about spatial data, and many of the challenges that data science faces we've been exposed to for a very long time. So there is no agreed upon definition of geographic data science, or even just data science itself. What I really like is to think about it as the whole process of gathering data, massaging it into a form that we can work with to make it tell its story, and then to present this story to others, either to peers, scientists, industry experts, or to the public. And depending on the audience, obviously, we have to make choices of how complicated the analysis can be, or the visualization, and what to include and what to leave out. Now, specific to geographic data science is that we often deal with data that incorporates spatial and very often also temporal elements, particularly, of course, later on in the examples which relate to movement data. So turning these increasingly large spatiotemporal data sets into insight and understanding is kind of the goal of geographic data science. And if we want to build a successful teams that can do data science that actually has an impact, it's not enough to just have geographers in the team, and it's not enough to build a team just out of computer scientists. I'm convinced that you need an interdisciplinary team to actually do geographic or spatial data science, because there's just too many fields for an individual to cover, from maths and statistics and computer science over the ICT and engineering domain to the humanities, including geography. And particularly, we have to counteract the strong opinions of computer scientists with critical thinking, so what is mentioned here is critical data studies, to tell them, yeah, your computations are awesome and it's great that you can do it really fast and on really big data sets, but think about the data quality. So I think this part of data quality assessment about understanding the data is where geographic visualizations play a large role. So what I will be focusing on mostly for the rest of the talk are two aspects of geographic data science. It's the spatial analysis together with the data visualization. Obviously, you can do spatial analysis, and it has been done for a long, long time, even without a graphical user interface. So you can do it completely automated. You can do it on the command line. You can do it in the database. And you don't even need to look at the data. But that's all awesome. It is still essential, I think, particularly if we are exposed to new data sets which we don't fully understand, and that is very often the case in geographic data science right now, because we don't control the whole data collection process. If you think of access to social media data, you don't exactly know how the data was collected. You don't exactly know how it was sampled, which pre-processing steps it might have gone through. So you need to have a look at the data. You need to try to understand it, and that's only possible really if you can visualize it. So this is part of the analysis process, or even a precursor to the spatial analysis. And on the other hand, of course, once you have a final result, you will do some information visualization for an outside audience, for public. So that's the other part of geographic data visualization, which is equally valid, but we shouldn't let ourselves be limited to this just making results pretty in the end. I think the visualization also has to be an integral part of the data science process. And that's what I try to show with this little diagram, which basically has this one core circle between data collection, data processing and cleaning, and exploratory data analysis, which is really an iterative process. So we cannot just go, okay, we go out once, collect the data, then we know already how to process it, and then we do our confirmatory statistical data analysis, and then we write the report. That's an idealized workflow that rarely ever happens in the real world. Instead, what we usually figure out is after the first data processing and cleaning, we need to have a look at the results. Then we realize all kinds of issues. So it's a back and forth between exploring the data and processing it, trying to clean it, make it better, figuring out, oh no, there's a gap somewhere. We need to fill it. So we need to collect more data. And that's really the part where I think visualization and spatial data visualization can contribute a lot to the established data science workflows. And with that background, I really want to dive into a couple of examples from my field of research, so from mobility research. And I'm sure you have seen some of those maps one or the other way. In the upper left corner, you can see fitness tracking GPS tracks from Strava, which are very popular for different urban mobility analyses. The maps are awesome to look at. Of course, we have to be aware of all the limitations. The bias in who actually buys those fitness tracking apps, who uses it, and who might not be represented in those tracks. But if we take those things into account, I think it's a very valuable data set. On the upper right corner, you see an example that has been published quite a while ago now. It's the taxi trip data published for New York City. So in this visualization, you see which are the busiest places for the city taxis. And this data, because it has been made publicly available for free for download, has been used in all kinds of research, even if it just contains the origins and the destinations of the trips, and we don't actually know how the taxi got from A to B. In the lower left corner, on a completely different scale, we have an example of vessel movements. That's a really exciting data source, which I've been dealing with quite a lot over the last couple of years, which is a bit odd for someone living in Vienna since we don't really have sea access. But it's really exciting to try to gain insights from this kind of movement data, particularly, in my opinion, because there is no underlying road network. But even then, we can still identify major paths, and we can do all kinds of analysis like travel times or routing suggestions. And there's even evidence that suggests that the paths the ships take and particularly their exhaust influences the local weather. So there's really a lot of topics that you can look at with this data as well. And in the lower right corner, finally, there's an example of a more regional analysis, which Eric Fisher did, to compare different types of users in social media, so the locals versus the tourists, and how they move through a city based on where they take pictures and at which time of the day and for how often. So all these data sets, they are related to how people and goods move through an area, and that's the context of mobility data science that I will be talking about. So we already had some of the data sources in the previous examples. Additional ones would be, for example, from cell phone network data. So whenever the phone connects to a cell tower, there will be a record somewhere in a database, and those can be analyzed, obviously, to learn about human movement. And that's been done a lot now in the context of the corona pandemic, obviously. Alternatively, you could also install a dedicated app on your mobile phone, of course, then you have access to more detailed location information, because you might have access to the Wi-Fi and the GPS of the phone. So that's how you would track people usually, if they agree. Obviously, there's also a lot of vehicle tracking systems that have been established for logistics purposes. So those are very classical, like the taxi example beforehand. And even just check-in data from services like Foursquare, or even payment data. The company that deals with your payments will know which store you visited and where you paid something. So that might also be used as a data source about movement data. If you're interested to learn more about those data sources, the potential problems of the data that you can get from there, I invite you to watch the video I have linked in the bottom right corner, because I will not be able to go into all the details in this talk, obviously. I just want to show you a couple of things so you can get a better impression of what kind of application we've been building in the last couple of years. So we had this collaboration with mobile phone network data provider. And what that gives you, of course, is not a very detailed spatial information about the whereabouts of a person. You only know which cell their phone is registered in. However, if you take the whole customer base of a provider together, it still gives you very valuable insights into different patterns. For example, what I'm showing you here is the distribution of people in over space. And I want to particularly highlight this area in the south of Vienna, which is one really large shopping center just outside the city. And if you look at the derived information from the movement, such as how long do people stay in hours. So most of the people spend 1 or 2 hours here, then it drops down to 5 hours. A couple of people spend around 8 hours, so that might be their workday, while the others might be the visitors of the shopping center. And you can also see the arrival times, so it's not very busy in the evenings when the shops have to close, obviously. And these kind of patterns, you can look in all the different regions, every cell that we have here in the map, and you will see a different kind of distribution depending on the land use in this area. So we tried to classify the land use based on the cellular data, and then we compared it to a classic authoritative land use map to see if that's anywhere close. And in Vienna, we have very good authoritative land use maps. But what is really exciting, of course, will be to transfer these learnings to different areas, to cities that maybe don't have these kind of land use maps yet, or who expect that their land use maps may be outdated. So it will be really exciting to see how the land use differs from what the official data says. Even larger than the mobile phone data in geographic extent obviously is if you have access to the global shipping data, which is provided through what's called the automatic identification system. So every ship above, every vessel over a certain size has to have an AIS receiver, and they have to broadcast their information. And anyone who puts up an antenna can receive those broadcasts within the receiver range. And there are platforms to share those with other receivers. So theoretically, you can get access to millions of records per day, and you can analyze them to find out more about it. What we've been doing is we've been trying to predict how vessels will behave, so how they will move in the next couple of minutes. And in this small visualization, you can see one of the intermediate results that we had. So you have the blue arrows, which just indicate if you predict that the ship continues to move in a straight line in its current course with its current speed, versus the pink arrows that are machine learning results and the prediction based on what we have observed in the past. So in the past, we observed that ships slowed down, that they moved in a certain direction, that they changed course. And by training a machine learning model, we can create a representation of the typical movement in an area and use that for these kinds of predictions. The last example that I want to show you is also based on taxi data. The only difference to the previously mentioned one for New York is that in Vienna we actually have access to the whole GPS tracks of the taxis. So what you can see in the animation on the right is actually just 1 hour of these GPS tracks from, there's around 3,000 vehicles in the fleet. Obviously, they are not all operating at the same time, but still in 1 hour you can see the city street network develop really well, and you can imagine how much insights can be gained from that. And one of the most recent examples that we did was a bit more than a year ago right now. Just the first weekend of the lockdown, we did this analysis of mobility demand and how it was impacted by the sudden restrictions that were imposed. So you can see here the center of the city, the first district, as well as the main train station in the south, which is the other dark pixel in this visualization. And you can see on Fridays, Saturdays, Sundays, and Mondays how there's a very stable pattern of lots of activity in the city center and at this main train station. And then suddenly in the second weekend of March, on March 14th, we have this lockdown and it gets quiet. There is still a bit higher activity around the main train station, but it also slowly fades away until there is almost nothing going on anymore. So this is just one thing that we can do with this taxi data, almost in real time, of course. However, taxis, ship data, whatever source we have, there's always messiness. There are always problems with the sampling. Maybe we don't get enough data. There might be gaps in it which we have to fill to do our analysis. And obviously the taxi drivers are not your typical drivers. So this data set is just as biased as the fitness tracker sets that I talked about before. And many other data sets are similarly biased in one way or another. So what we really need to do in critical data science is to uncover those biases and try to understand the consequences of using biased data in our analysis. And I think that has to happen through data visualization and exploratory approaches. So that's really the core contribution of spatial data visualization to data science that I see. And here I wanted to bring you a short animation of data exploration and how it can be done in QGIS. I let it run and I try to talk a bit with it. Maybe we let it run twice so you can see all the things, because it covers, as you can see right now, the attribute statistics that you can calculate, and now we will be also visualizing those on a map. For example, the speed of this hurricane data set. So you have the symbol data size that you can make data dependent depending on the speed value, or obviously that's also possible for the colors. And really these data-defined assistants that I'm showcasing here are a really convenient way to configure the symbology in a way that makes it possible to explore the data really interactively. As you can see, whenever I change something in the layer styling panel on the right, it's immediately reflected on the map. So all the little tricks like typing in the word world into the coordinate input field in the bottom to just bring in a map of the countries. That's the first example. Then you can drag and drop layers into QGIS and bring in those shape files in this case to visualize the data set immediately without having to go to any add layers and then navigate through the folder structure. It's way more interactive than that. It's more about trying to understand the data and changing things as you realize them, than always going to layer properties somewhere, changing something, clicking on OK, and then checking how does the map look like right now, and then having to go back to the layer properties. And instead we can do this really interactive way, which makes it possible to explore the data in just much more depth because it's so much faster. If you want more detailed explanation, I encourage you to watch Niall Dawson's presentation from Phosphor-G Oceania 2 years ago, because it can go in much more detail. It's 20 minutes of just exploratory data analysis with QGIS and all kinds of tricks. One thing when we deal with mobility data, obviously, is the temporal aspect, and I want to touch on that right now. So what can we do to represent time on a map? There are a couple of tricks, but the really intuitive way is just to have spatial temporal visualizations. So like here, visualizing how the public transport vehicles move through the city is a really good way of having a first look at a data set and trying to understand where things might be going on and where there might be gaps in a data set. So to create those spatial temporal animations, in QGIS particularly, we had for a very long time the Time Manager plugin, which I developed. And right now, actually the functionality of Time Manager has been incorporated into the main application of QGIS, and it's now called the Temporal Controller. No matter which QGIS version you have, you will have access to one or the other. And what it gives you is basically the interface of a video playback system, and it allows you to configure vector layers or raster layers in their temporal order, and to basically have a video run inside your QGIS application. And you can have either one timestamp for each feature in the attribute table, or you can have a start time and an end time, and all those different combinations are possible. But QGIS is not just limited to geographic and spatial temporal visualizations. There's also tools to create other plots, which can be helpful to have in parallel to the map. And one main development has been the Data Plotly plugin, which is showcased in this animation here. And as you can see, it is synced with the map, so you can highlight features in one representation, and they will be also highlighted in the other representation. So like here in the scatter plot that we see on the right-hand side, and then the user can pick either individual points in the scatter plot or highlight a certain area of points, and they will also be highlighted on the map. So this gives you a lot of different plot types. There's also histograms and violin plots, which you can use to explore the data distributions. Lately, this has also been integrated into the map series tools, so you can not just use them interactively, you can also add those diagrams to the maps that you produce in the layout, in the print layouts. Like in this example here, let me restart it once more. You can see a map series configured to go through all the different countries in the dataset. And as the map updates, so does the diagram, the Data Plotly diagram in the bottom. And this is really powerful to build automated reporting tools, obviously. So beyond this interactive visualization, which we do to talk with other researchers or domain experts and to exchange ideas and to test hypotheses, obviously we also want to create good-looking maps for presenting the final results, and that's what I've called information visualization on this slide. And that's also where, if you want to dive deeper and you haven't had a look yet, I encourage you to look at the QGIS Map Design Books, which give you some examples of what can be achieved just with the QGIS layout designer, like maps with different insets and labels and different projections, obviously all synced together. And I already mentioned before the automatic map series generator. All those things are discussed in here in great detail with examples that include QGIS project files and data files, so you can immediately get started. You can swap it out with your own data and apply it. Some really powerful tools that are not so well known, and that's why I want to highlight them here in this talk, in QGIS are the so-called geometry generators. And really what they do is, on the fly, while the map is drawn inside your GIS map view, it generates other representations of the data. So what you can see here is on the left-hand side, this inspiration that I had, this map of trade relations between different parts of the world and which are connected by what to me looks like conveyor belts. And I took this inspiration and I tried to reproduce it in QGIS. So on the right-hand side, you can see what I came up with after a while. And basically, the only data layer that exists here are 3 lines connecting China to either Russia, Europe, or Australia. And they have attributes that describe how strong this relationship is. But all the rest, like the circles, the conveyor belts, the tiny arrows around the circles, they are all generated on the fly without any additional data sets in the background clogging up your hard drive. They are just on the fly buffers on the endpoints of the lines, which are then connected together in the surveyor belt style. And you can also use it to make connections between different layers. So in this example, this is just one short statement of how to connect the different districts of this, in this case Vienna, so the polygons, to one specific station of our city bike sharing system. And in this case, you could just swap out the name of the station to a different one and the map would automatically update. So nowhere on your disk do the lines connecting the districts and the stations exist. It's just on the map, and that's what geometry generators are great for. They can also be used in labeling. So Klaus Carlsen, who publishes a lot of different examples all the time, he's super creative. Here he shows how you can automatically label one layer based on the features intersecting the features in another layer. So you have this ellipsoid on the left is just intersecting the rectangles A and C, and the other circle is intersecting all of the rectangles, so it's labeled A, B, C, D. Or on the right-hand side, you can see him how he does place those nice measurement styles. And the really cool thing is it's now possible to share those styles with other users. So if you want to share your symbols or geometry generators, whichever level of sophistication you want to work with, you can do that right now. And you can provide them as download on what is called the QGIS hub, and is now also integrated into the QGIS plugin platform. It's not limited to styles. You can also share layout templates. So, for example, there's this nice Instagram format with a square map that Klaus has shown on the left, or a regular A4 standard map with all the all4 information and map set information like here in the middle. So it's really convenient way of establishing visibility for your map designs and providing something back to the community. Even if you're not a developer, you can get involved in the QGIS community, for example, by sharing these kinds of styles and layout templates. So to go back full circle to where this talk started and to the title of the talk, let's also talk about spatial analysis. Obviously, QGIS loves spatial analysis. If you've ever had a look recently at the provided analysis tools, they are all listed in the processing toolbox. All these entries have dozens of sub-entries of different algorithms for analysis, and all the ones with the small QGIS icon, they are built in by default. And then you can extend the functionality via all kinds of plugins. So here we see again the Data-Plotly plugin has some algorithms, and you might have edge bundling algorithms. That's a plugin that I've developed, and many, many other providers. So it's really endless, and you can mix and match algorithms from different sources to perform your analysis. You can automate your analysis by either building what's called processing models with the graphical interface, or by writing Python QGIS scripts, which can run either inside of QGIS, or they can also run standalone on a machine where QGIS is installed, but they can be run from the command line if you wish so. And what I'm really looking forward to seeing in the future is to have a closer integration with Jupyter Notebooks. So if you've ever seen those, we will have a couple of examples later on. But it's this interactive programming environment which gives you an immediate connection between the code you write and the output it generates. And I think that's probably the future of a lot of spatial data science interactions as well. So there are tons of tools. For example, going back to the movement analysis topic, obviously for shortest path, computations for isochrones or catchment zone analysis, for origin destination matrices. There are tools that use only your local data, so you need to provide, for example, a street network and the allowed travel movement speeds and the travel times on these network links. But there's also a lot of plugins that will calculate these values, or which will fetch the information from web services, so that They might be using either OpenStreetMap-based web services such as Open Route Service, or it might be using services provided by, for example, here for creating these catchment areas. And there are also other algorithms, like I mentioned before, the edge bundling, which turns the raw line-based visualizations into nicely bundled representations of the main flows between different geographic areas. That can also be found in the processing toolbox, because it's also a way to handle geographic data. And so from basic data processing to almost visualization tools, everything can be part of the processing workflow in QGIS. And after so much QGIS, there's another growing open source GIS or spatial data visualization and analysis environment that I really want to talk and introduce you to today, and that revolves around the pandas ecosystem. So pandas is a Python library that was developed for data analysis mostly in the financial world, and has recently been extended with GeoPandas to also support spatial information. So you can think of it, it's very similar in development like the Postgres databases, which are extended to spatial databases using the PostGIS extension. So you have the same kind of thing happening right now in these data analysis libraries. You have the basic pandas library and you have the spatial extension called GeoPandas. And my contribution to the whole ecosystem has been in the last couple of months to develop the Moving Pandas library, which uses the spatial capabilities and makes it possible to deal with movement data more conveniently. So what can you do with these analysis libraries, and particularly how can you also have a look at the data and not just process it on the command line? There are some really cool libraries. Obviously there's default plotting, which is also kind of neat because you don't have to install anything extra, but there are also really good interactive maps. And here you see just a couple of examples. So the libraries that I want to highlight are called hvplot and GeoViews. And they provide really easy access to background maps. Like here you can see it fetching background Esri tiles for the point map it creates. You can also reproject your data, so you're not limited to what's usually happening in web maps. You don't have to do web Mercator or pseudo Mercator maps. You can also do other cartographic. You can also use other cartographic projections. And obviously you can create all kinds of choropleth maps as well as heat maps, density maps. It's not as powerful yet, obviously, as QGIS, but particularly for data exploration, it's a great place to start, and I encourage you to give it a try, particularly if you have a bit of experience with Python already. One place you might want to start with is the tutorials that I've prepared for Moving Pandas. They start at a really low level and don't expect that you are very familiar with Python. And you don't need to install anything on your own computer. You can just run it in a browser, which makes it really neat as well. But this is basically how a notebook looks like. And in the next animation, you can see how it works. You have all those blocks of code, which are called cells, and you can run each block individually, and whenever it is done running, it will provide you with whatever output it generated. So in our case, that can also be a map, like this interactive map of one GPS track where I used stop detection to find out where the moving object was standing still, or at least moving very slowly for a certain amount of time. So there's all kinds of functions in moving pandas, and you can put maps side by side. Like here you can see on the left-hand side the stops that we previously detected, and on the right-hand side you can see how we split the original track into individual segments between those stops. So we might want to run an analysis on each segment individually afterwards. And it's really convenient to be able to place those views side by side. Also, if you zoom in one, the other one is automatically synced, so it follows your interactions. You can even combine maps with non-spatial visualizations, like in this example. That's also something that you can find out more on my blog. That's the Ever Given situation, so the ship that was stuck in the Suez Canal a couple of weeks ago. And you can see on the left-hand side some of the stops that I detected in the ship movement data. So every blue point is a stop, and you see 3 different clusters in the north of the canal, in the middle, in this lake, and then on the southern end of the canal. And when I'm highlighting only the stops inside the lake, in the central cluster, so to say, you can see how on the right-hand side in the diagram, the corresponding points are clustered in regular intervals. So that's where ships have to wait basically until it's their turn to pass through this narrow southern end of the canal. So every couple of hours it's their turn, and then suddenly when the Ever Given gets stuck, this whole system breaks down, and obviously nothing moves anymore. And since this data set ends before the whole situation was resolved, also you don't see it recovering anymore in this small example. But that's one way how you could find patterns, and in other situations they might not be so obvious, of course. If you want to learn more about Jupyter Notebooks and how spatial data exploration can be done with these tools, I encourage you to watch the FOSDEM presentation that I gave in February. There I have also included other examples that are not just from movement data, and different notebooks can be found online that you can play around with. But really, all this is just the tip of the iceberg, and we could dive into any one of these topics for hours on end. So I want to highlight a couple of particularly YouTube channels that can be helpful to discover, to get a better understanding about how those things work and to try to reproduce them. I already mentioned Klaas before. He does tweet a lot of creative cartography stuff. He also has a really awesome YouTube channel where he does analysis and visualization topics. So I encourage you to watch that one. There's also some really great material published by the QGIS developer Niall Dawson, which you can find online. Like here, he talks about how you can set up different styles for the same layer. So the city labels, as you can maybe spot already here, Brisbane, once the label is rather large, and in the other subset map it's rather small. However, it's just the same layer, only the style is different. And he explains in this video how you can configure all those tiny details without having to duplicate the layer multiple times in your project. So it's really exciting to find out all those neat little features in QGIS, which might not be so obvious at all. If you're not a big fan of Python, but if you're coming from the R world of spatial analysis, there's also good news. There's more development in integrating R into QGIS. So Hans has just published a tutorial of how to use R in QGIS, particularly on Windows. So I'm looking forward to giving that a try as well. And more we see also larger organizations like AI for Good and the UN picking up QGIS and also contributing to the tutorials that we have available. So AI for Good has published a couple recently about satellite data analysis and classification, which are really good and also have material to work with, to work through the tutorials. Similarly, there is also a monthly QGS Open Day, so the next one is on Friday, which I realize no, it's not overlapping because your conference only runs until Thursday, right? So on Friday, you could join the QGS Open Day and see other presentations. For example, Ujjwal Gandhi's presentation about how to do network analysis with different plugins in QGIS. So with that, I want to wrap it up. I'm looking forward to all your questions, and I hope you enjoyed this presentation.
Thank you, Anita. So at this point, I'd be happy to take any questions that people want to post into the chat. So let's see some questions come up there. There is one question already that has come up from Byron, so perhaps I'll start with that while we wait.
Sure.
So Byron asked the question, and by the way, Anita, thanks very much. That was a really interesting talk before I launch into the questions. I have some questions too that I can fall back to if need be. But Byron asks, your conveyor belt map using geometry generators is a cool design, but obviously not an out-of-the-box symbolization. How much do you think pre-packaged design options in QGIS and other GIS packages inhibit creative map design?
Yeah, that's an excellent question. I think it certainly inhibits many users because they fall into the trap of just using the defaults because they're quickly throwing something together and they're not thinking about how to best represent their data, so they just pick something that, yeah, okay, this will work. So you can really sometimes tell which software tool a map is made with because it consists just of so many default visualizations, right? However, I don't think that means that we can leave out a certain default style set, because if you don't provide anything, then people will be really confused about where to start. So it's hard to balance those. We've added a couple of really weird default styles in QGIS over the last couple of versions. So I hope that inspires people to look into more of the styling settings. For example, we have the cat paws style. So it's a line style where your line left and right is followed by cat tracks. And I hope that people click on it and then they realize that it's just small SVG markers that alternate between the left side and the right side of the line, and then they can dive deeper into how to customize that. And I hope that's a good way to go.
All right. I'm not seeing anything else in the chat right now. So one question I had, which is from early on in your talk, you were talking about geographic data science as an interdisciplinary activity, and the contributions that people with computer science background as well as in the humanities can make. I guess my question to you, again, coming from my perspective as somebody who's teaching GIS and cartography and geography in Canada, is how do you think geographers and cartographers coming out of university and college today need to be prepared to actually participate in the marketplace that's developing?
My personal opinion is that I think they should have some exposure to how computer scientists think, because it will enable them to talk with those people. And so I'm really a fan of exposing people to how to develop a basic Python script in QGIS, or nowadays how to use a Jupyter Notebook with some GeoPandas to load a shapefile or a GeoPackage and to manipulate it just using code. Because it lowers the barrier or the perceived barrier that sometimes people feel like they run into if their background is solely from the humanities side of things. But similarly, I would appreciate if computer science courses would include some more mandatory classes on things like critical data science, where you actually think about what it means to represent people as numbers in your database. So I think both sides should have a bit more interdisciplinary courses in their curricula, so that the teams that I've been talking about, those data science teams, can work well together.
Right. Excellent answer. Yeah, communication is so important in all this stuff. One more question coming up. Amy Wilson has asked in the chat, for someone new to movement data sets, which QGIS plugin do you recommend looking into first? You mentioned some plugins that automatically fetch open data sets, I think.
So the plugins that use more or less open services, they would be related to mobility analysis, like routing services, so how to best get from A to B with different modes of transport, or to find out which areas could be reachable within, for example, half an hour of driving by car. There is things like the ORS toolbox or the QGIS plugin, but you can find a whole blog post comparing different ones on my website. For real movement datasets, and that's usually when I say movement datasets, I mean GPS tracking datasets. That's the most common type. There is no plugin that will automatically download some of those for you. But there, for example, in the OpenStreetMap projects, you will find what's called OSM traces. That's where people voluntarily upload their GPS tracks for mapping purposes, and you can download those from the website. There's also the ship data that we've analyzed is available from an FTP server, from a public one. The taxi data from New York is public, but so far there is no single plugin that will just download that data. So unfortunately not. For the analysis of the data, what I'm really looking to do in the next couple of months is to bring moving pandas back into the processing toolbox. I originally started out developing it as a QGIS plugin until I realized that, well, there's so much under the hood that I have to take care of first, besides the QGIS integration per se, that I extracted this basic handling of the movement data, and it's now its own Python library, and eventually I want to bring that back into QGIS, and there are plans to make this interaction between QGIS vector layers and raster layers representations and Python representations in pandas more seamless. And once we can go back and forth between pandas representations and QGIS representations, I think that's when I will bring all the analysis tools like stop detection and splitting that I showed you now in the context of Jupyter Notebooks. I want to bring that back into QGIS via the processing tools. So stay tuned, follow me, and you will see how that develops in the next couple of months.
Okay, that's really interesting. I will watch for more pandas integration, and that'll be a good thing, I think, to point some of our students at. Mm-hmm. Blair Scriven has asked a question, which is, where would you suggest someone start if they want to learn how to code plugins in QGIS, if we already have some Python experience?
If you already have Python experience, then I would just grab a plugin and look at the source code and take it from there. Additionally, there is a plugin called a plugin builder. So we have a plugin for building plugins. And what that does, it creates you the skeleton, all the files, all the different pieces that you need as a boilerplate code, and then you just fill in your custom functionality and logic. So that's a really great place to start if you're already familiar with Python and don't need any tips on how to do basic things. However, if someone else in the audience is not yet familiar with Python, then you can go to my website, and there is a PyQGIS 101 class, which currently has, I think, 11 exercises that do not assume any previous Python knowledge, and it walks you through first using Python inside QGIS on the Python console, and then it goes to writing scripts and integrating them into the processing toolbox. So that would be for those of you who maybe are not so familiar with Python yet.
All right, thank you. Klaus Rinner has just posted a question, a greeting and a question. He asks, so I'm curious about your geospatial data science diagram that combines the associated disciplines such as IT and geography. Is this your work, and is it shareable on Twitter or in class?
Hi Klaus, long time no see. And the answer is yes. Both the diagram about the data science workflows as well as the one about the interdisciplinary nature of geographic data science, they are both my own work. So you are free to share them wherever you want.
All right. Don't see any other questions in the chat right now. I love the geovisualization that you showed of the Ever Given. That was actually one of the questions when you first showed the ship track, was I wonder if you saw how the Ever Given affected the transits through the Suez Canal. So you said the data that you've got right now only shows until just before that blockage cleared?
Right.
So how often does that data set that you're working with get updated, or is that one that you have to sort of dig for?
So that particular region is not included in the sources that I usually access. So Egypt is not included in the public download services that I have so far been able to localize. But I follow a couple of data journalists on Twitter, and I saw them very quickly publishing a time manager or temporal controller versions of ship movement maps, and I just asked them if they would be so kind to share the data set with me. And they went to their provider and they agreed that I could use them for this demo visualization. So it's not always easy to get access to those data sets for all around the world. You really have to dig for them. That's part of the challenge. Like everywhere in GIS science, if you're not using remote sensing imagery, I guess.
Right. So the key is, once again, communication. Yeah.
Knowing people, don't be afraid to ask. Yeah. I can always say no.
That's right. All right. We have time for a couple more questions, I guess, yet. So sure. Matthew Ladd has asked, I have used PG routing in Postgres. Is there a similar routing tool in QGIS?
Absolutely, Matthew. So there is actually a PG routing plugin for QGIS that will connect to your PG routing enabled database and provide you a front end to use it. But there are also lots of plugins that work without a database in the background. And as I said, some of them will use your local street network dataset if you have it, and others will just take your input and they will query a web service and visualize the results. So again, I can afterwards maybe post a link to my blog post, particularly on routing tools, here in the chat. I will dig it out and share it with you.
All right. Thank you very much. I don't see any other questions in the chat right now. We probably have another minute or two for another question if something comes up. Otherwise, I think we're almost winding down. thank you very much again, Anita. Your talk was really interesting, and I'm delighted that you were able to join us today to start off our conference.
Thanks again, and have a good conference.
Thanks a lot, Anita. Not seeing anything else, I guess I will just let this wind down for now. So thank you and have a good day.
Bye.
Okay, bye-bye.